All right, we are talking about factoring, which is one of my very, very favorite F words. I love to factor, and we are going to use three different ways today: GCF, factoring trinomials like this, and not that we would necessarily factor that one, I just made it up. And then the difference, remember the word difference means subtract. And perfect squares are things like these. So we're going to talk about all these different ways. So greatest common factor, and something about factors, I'm gonna kind of go back to the very, very basics here and show you prime factorization. And you do not have to do this every time. But if I did break this down, 12 is 3 times 4. If I broke this down into our prime factorization, it's easy to see the GCF. Oops, I didn't mean to erase. I wanted to highlight. They both have a 3, and they both have 2 x's. So when I factor this out, I'm left with something like this. Well, we don't write it like that. I am left with this. And now maybe you looked at this right away and you thought, well, I know the GCF for 3 and 12 is 3, and x squared and x cubed is x squared, and I am left with then x plus 4. If that doesn't come naturally to you yet, then think about prime factorization. When there is a negative, you need to make sure that you factor out the negative. A leading negative, I should say. So similarly, I can see that they both have an x, and I know that 3 goes into 48. So I'm going to factor out a negative 3 and an x. And when you think about like dividing these, it's another kind of way to say factoring. I'm left with x squared. And if I take 48 and divide by negative 3, I'm left with a negative 16. And I want to come back to this one on my third slide, because this is the difference of perfect squares. Okay? And so I'm going to come back to that one. I'm going to bring it back when we get to our third slide. But for now, first, take out the GCF. Sometimes you have to use more than one type of factoring. You should always look for a GCF first. Okay, when we're working on trinomials here, hopefully you remember that you take this number at the end and come up with factors. Isn't that weird that factoring has to do with factors? And so if I listed all the factors of 18, 3 and 6, and then I would go back to, right? And then if I was talking about negative 18, I could make all the first number negative, and then I could write these again with the second number negative, which I kind of did when I did these all. So I need to come up with the combination of these two factors that adds to positive 7, and I found it right here. So it needs to add to positive 7. So the two factors I'm going to use are these, and I'm going to write my factors like this. Now I forgot to mention this on the first one. How do you check to see that you're correct? Well, another favorite F word of mine is to FOIL. And so if I FOIL this to check, I get x squared plus 9x minus 2x plus negative 18, and I get x squared plus 7x minus 18. Oh, I did it. Check. All right, so if you don't like to FOIL, some of us don't like to FOIL, there's that box method, right, where you would put your x minus 2 and your x plus 9, and you would get the same answer. So similarly, when you have, though, a positive number, remember you could have 2 positives or 2 negatives. And when I look at this negative 14, I know I need two negatives. So my factors of 49. I don't think 2 goes into 49. I don't think 3 goes into 49. So remember, I'm just taking my calculator if I need to and dividing. 49 divided by 4. Nope, 5, 6, 7 times 7. Okay? Well, this is the only one that adds to negative 14. So negative 7 and negative 7. Of course, I ran out of room. Typical of Miss V. To run out of room, my factors are x minus 7 and x minus 7. And again, you could use that word FOIL to check that you did it correctly, or the box method. Okay, so factoring trinomials, you look for factors of the last number that add to the middle number. This should be very much review for you. You did this in Algebra 2 and Functions in Trig. The last one I want to talk about, and before I get too far, I want to bring back this negative 3x cubed plus 48x. Okay. The difference of perfect squares. And so when you see these, like, think, can I take the square root of this and get a number? And can I take the square root of this and get a whole number? Yes, those are what our perfect squares are. So maybe you need to remind yourself, what are perfect squares? If I took 1 squared is 1, 2 squared is 4, 3 squared is 9. Okay, so you could make a whole list. These numbers over here are all perfect squares. You could keep going. Okay, I know you could make a long list of them. Things that are also perfect squares, if I square x, I get x squared. If I square x squared, I get x to the 4th. Okay, these things are also perfect squares. So just kind of be on the lookout for that. These numbers can be perfect squares as well. So it has to be the difference, meaning subtract. And why is that? Because what happens when I factor these, either by the pattern that you notice, or by thinking about what makes a 0 middle term here. When I add these, let me FOIL these for you. Hopefully you see what happens here is this middle term drops out. Okay, so then all I'm left with is a squared minus b squared. And they will all follow this a minus b, a plus b pattern, where a squared, a is the square root, b squared, b is the square root of that. So what does that mean? X squared minus 36. Well, look at here. The square root of x squared is x, and the square root of 36 is 6. So I do have two perfect squares here. So I know it's going to factor into that plus minus, okay, one's plus, one's minus pattern. And to check it, I would FOIL. Okay, and this middle term would drop out, and I would just be left with x squared minus 36. Okay, so any of them that follow the squared in the front, minus, no middle term, squared in the back, will follow this pattern. It does not have to be x squared with no coefficient. It could be 4x squared. If I think about the square root of this number, it's 2x, and the square root of this number is 9. So 2x plus 9 and 2x minus 9. Okay, a lot of us forget about this. The square root of 1 is 1. The square root of 9x squared, it's really messy, is 3x. So 1 is one that we forget about, but I did write it over here. This one will factor into 3x minus 1 and 3x plus 1. And then from earlier, I factored out this GCF first, right? GCF. And there was an x there. I got x squared minus 16. And now, it's so hard to read, Miss Vogt. Now we're just going to regular factor, as I think of it. I still have my negative 3x out there. But I noticed x squared and 16 are perfect squares. So I can factor this into a minus 4 and a plus 4. Okay, this is our first type of factoring. There will be 2 more videos on factoring. Please make sure that you are writing things in the margins and you are pausing and asking questions so we can go over them in class.